In this video, we're going to have a look at similar shapes. In particular, we're going to have a look at problems that require a linear scale factor to be used in order to solve them. We're going to have a look at two definitions. The first definition is congruent. Shapes are congruent if they have the exact same angles and the exact same length of sides. So if we have a look at the shape on the left and on the right here, you can hopefully see, if I select my pen icon here, you should hopefully see that they all have the same angle, and you should also hopefully be able to see that the corresponding lengths are the same. If this is 8, this is 8. If this is 3, this is 3. I could rotate one of my shapes, for example, but it would still be congruent because the angles would be the exact same as would be the lengths of the sides. More importantly though, at National 5 level, we look at similar shapes. Okay, shapes are similar if the corresponding angles are the same and the corresponding sides are in proportion. When we talk about corresponding angles, we mean things such as this angle here is the same as this angle here, and this angle here is the same as this angle here, for example. Okay, so we can hopefully see here, yeah, all these are right angles, so that's absolutely fine. The next definition we need to have a look at is that the corresponding sides are in proportion. For example, do you notice here that to get from here to here, we have halved, or we've times, we've multiplied by 1/2, and we've done the exact same operation to get from here to here. We have multiplied by 1/2. Okay, so as long as the same operation is done to all sides, then this would be a shape that is similar. Usually in National 5, the question will say the shapes are, or the following shapes are mathematically similar. That should hopefully be a trigger for you to think, oh, and hopefully when you see this video, it will show you along the process of what you have to be doing. But if you see something saying mathematically similar, you just think, ah, right, I know what to do here. This builds up, it's usually worth 3 marks in a final exam, but we're going to build it up through the next few lessons. Okay, so I'm going to actually take a wee note of this example down. You might need to pause the video. So the following shapes are mathematically similar, right? I need you to see this and think, ah, right, this is the clue. If it says in the question that the shapes are mathematically similar, you should be thinking, oh, okay, right, this is like something that we can just follow the process here. So that means that the corresponding angles are the exact same and the sides are in proportion. So if we have a look at here, we'll just try and show which sides are in proportion. I would say that this side is in proportion to this side. I would say that this side is in proportion to this side. Okay, so we're going to look at the sides that we have all the information for. The sides that I've highlighted in green, we don't have everything for, but we do have everything for the sides I've highlighted in orange. We can hopefully see that our value for x is going to be bigger than 9, okay, because it's obviously going to be much larger than the 9 centimeters shown here. Okay, it's obviously been enlarged from here to here, it's gotten bigger. So we'd say enlarge for that, there's been an enlargement scale factor. So we're expecting our value for x to be larger than 9. Okay, so what we do is we write down our scale factor. SF is going to stand for scale factor. And how we're going to represent that scale factor is the new shape over the old shape. Okay? The new shape is the shape that has the unknown in it. So if we have a look here, if I circle this in blue, this here is the new shape. Okay, so I'll look at the matching pairs of information that I have. I've got 20 and 4. So when I put this into my scale factor, I'm going to be my 20, because that's the new, that's the corresponding side that's new, and over the 4. So the scale factor is 20 over 4, which is 5. And you can probably see that already. Yeah, you should be able to see that from here to here, we've multiplied by 5. And because these are mathematically similar, to work out x, we're going to need to multiply 9 by 5. To go from there to there, we're going to need to multiply it by 5. So x is going to be 45 centimeters. Okay. Okay, one more example, then that's us. Okay, in this example, it says the following shapes are mathematically similar. Okay, so straight away, I'm thinking scale factor. Okay, scale factor. And to work out my scale factor, I take the new corresponding side and I put it over the old corresponding side. Okay, let's have a look at which sides are corresponding here. Which do I have the matching information for? Well, I've got this 30 and I've got the corresponding 12. Okay, so it's going to be 30 over 12 or 12 over 30. The new shape is the shape with the unknown. Okay, so in this case, my scale factor is going to be 12 over 30. Got a few options. We could simplify this fraction to 2/5. Okay, so my scale factor is 2/5. That means that from here to here, I'm multiplied by 2/5. Therefore, to work out x, we're going to do 50 multiplied by 2/5. Okay, you can do this in a calculator. You should be able to work through it as well without. We can simplify this 5 with 50. That goes in 10 times. So x is going to be 20 centimeters. Your other option here is you could have input this into a calculator, done 12 divided by 30 and got 0.6. And then at this stage we would have done 50 multiplied by 0.6. You would have got the exact same answer. Okay, hope that was helpful. Thank you very much.